In the field of fire alarm systems, certain codes and standards are utilized to enforce the rules and regulations of buildings, fire alarm systems, wire, so on and so forth. Let's take 2 minutes to learn more about our wiring code, or in better terms, NFPA 70, the NEC. Let's talk about it. Now, when you're utilizing the NEC for fire alarm systems, you don't want to use the index. There's about 10 pages of this book dedicated to fire alarm systems, and using the index can be kind of difficult. What you want to do instead is utilize the table of contents. You're going to need to utilize two keywords to find your information. Your first keyword you take to the table of contents to find what you're looking for. Go to that page number, and then your second keyword is going to be utilized to look at what do I need to know about that first thing. So that's how we're going to use the NEC. Now, when we look at the NEC, there are some other sections that could be applied to fire alarm systems that are also utilized. Key sections of the NEC. Chapter 3 is general wiring requirements. These are going to be things that are going to be found in pretty much all aspects of wiring. We have Article 760, which is the specific fire alarm system wiring article. It's about 10 pages long. You've got some tables to be aware of. The box fill table 314.16a, the use of Annex C to navigate your conduit fill tables, conductor properties table to find resistances of cable, Chapter 9, Table 8. And then lastly, a table specific to fire alarm, Table 760.154a, the cable substitutions table. Let's talk about these other tables. Now, Chapter 9, Table 8, the conductor properties table, is going to be utilized when we need to know about resistances of cable. The first thing it will take into account is that there are two numbers for every gauge. The top number is your solid cable, the bottom number is your stranded cable. We also have the factors of is it coated or uncoated. Most of what we work with in the field today is coated cable. Coated cable has a very thin layer of tin, nickel, or zinc on the copper itself, and the reason behind that is it prevents or slows down the process of oxidation, which is going to increase the resistance value of your cable over time. All of the values on this table are going to be given to you per 1,000 feet. The next table we look at is the box fill table. Here's how we recommend utilizing the box fill table. Identify the type of box you're being asked about first. Then move over to the left, identify the size of that box, put your finger down, scroll over, find the gauge of cable that you need to know about. That's how we recommend using the box fill table. The next table that we look at, or at least the next navigational tool, is going to be the use of Annex C when we have any questions come up about conduit fill. Use Annex C first. Annex C is going to tell you all the different types of conduit, and then you'll go to the corresponding page number for that type of conduit. Once you're there, identify the cable type, the gauge of your conductors, and then scroll over and find your size of conduit. And that's how we use the NEC.